We have the links, coreboot.org, mailing list, IRC on Freenode, #coreboot, coreboot.org/whatever, or check out Serialize or FlashROM or cbios.org. And maybe time for questions? A couple of questions, yeah? Yeah, let's.
Check. Test.
You said.
Check. Okay, one question is coreboot FS writable by the BIOS?
Is coreboot FS writable? So the normal way you use coreboot FS is this CBFS tool utility, which you use to put files into a coreboot FS image, and then you flash that image to a flash chip. I see in the future that CBFS tool and FlashROM will merge somehow, so that you can do the same operation, but that you can do it directly on a flash chip. In theory, it's writable in Flash. Yeah, sure. But yeah. So does that answer your question? Okay. So there were two more, I think.
You said 32-bit mode was entered first before initializing RAM. How is it possible? What about descriptor and interrupt tables?
So can you please repeat the question?
How is it possible to enter 32-bit mode before initializing RAM?
How is it possible to enter
32-bit mode, protected mode on...
protected mode without RAM?
Yes.
Just set the bit. It works, yeah.
Okay.
Yeah. Set the PE bit. You can, you disable interrupts and you set up the descriptor, the GDT to match the cache's RAM configuration that you're going to use, and then it works. And as long as you don't access any RAM anywhere, the CPU doesn't know and doesn't care.
Okay, I have a question. You mentioned this thing with the serial output for the debug, and
yes.
Then you mentioned you have your netbook there and so on. How do you get the serial port on the netbook? Do you solder something onto a chipset, or where do you get it?
It's so sometimes you can find the right pads to solder on, but the way chipsets and CPUs work these days is normally, or the capsules the packages that they come in is usually a BGA. So the connections are all underneath the chip, and you can't really access them. In that case, you have to rely on the USB debug port, or maybe you can find some other communications method. So there's a socket for the RAM here, and the RAM has this green SPD memory. So maybe you can use that I2C bus to send out debug messages, or maybe you can use the flash chip accesses. If you have a ROM emulator, you can set it up so that if you read from a special sequence of addresses in the flash chip, that actually translates to a debug output write.
Okay, the way I see it, then you mean like for your development, you make a patch to see what you're actually doing. It's just because in the list of software you said there was like sort of a standardized serial output, but in reality, it's not really used the way you explain it there. You would do
it is on a lot of boards.
You would do whatever to see some sort of output from your particular board.
Well, there is a standardized console driver, which is what the entire coreboot uses, and just outputs the console driver. And then what the console driver does behind the scenes, it can either be using a standard COM port, if there is one, or it can be using a USB debug port, as I mentioned, the programmed I/O on the EHCI controller, or it can be doing something else. But most systems either have a serial port or they have USB debug So we haven't really been forced to do any of these more creative solutions yet, but I'm sure we might have to do that sometime.
We are running out of time, so last question, please.
I was wondering if you could maybe highlight a couple of the facilities that libpayload would offer me as a developer for payloads. So how fun is it to code libpayload? What can you do with it?
You can do whatever you want in the payload. You own the machine. You're the only thing running on the machine.
What does it give to me from library facilities?
There is no real... Oh, you mean libpayload itself? Oh, okay. Well, Gee, okay. There's a console output. There's a PCI access... a PCI access library, there's NVRAM access, there's, what else is there? There's a graphics driver for G.LX and one for plain VGA. There's USB, some stuff. USB keyboard for sure, and of course PS2 keyboard as well. Serial port in out. I would have to check the source code. I guess we can look in a little bit and see what there is more. There's probably more as well that I don't remember right now.
One more question on the USB stack. I'm unclear about where the USB stack is sitting. It's in the CBIOS only? So the host support for USB keyboards? Or?
Good question. There are several USB stacks, more or less thin. CBIOS has some USB support for keyboard, the early stuff. Philo and libpayload together, well, okay, so libpayload has a low-level USB stack, and Philo adds mass storage on top of that. Of course, the plan is to get that mass storage also configurable in libpayload, but for now, I think it's still stuck in Philo.
And the stack, is it polling or is it interrupt mode? Is it busy polling? Is it running in SMM?
I'm not sure. I would have to check.
I'll read the source, okay.
Yeah, of course, read the source. I'm not sure. No, I don't want to say. It could be interrupt driven, but I sort of doubt it. I think it's polled. I'm not completely sure.
Are you by default using SMM mode in any?
No,
okay.
no.
You're leaving it untouched, you're not locking it?
It's, by default, it's not touched at all, so it's not locked. And most boards do not enable, do not use it. So it's free to use for payloads or whoever comes next. There are some boards that require system management mode support. So the G.LX is one example. It has the VSA, the virtual system architecture stuff, which is SMM. So their coreboot does initialize the SMM and sets it up and locks it as well. And also one or two Intel boards, or boards with Intel components are using SMM and should have it locked as well.
But then you write the SMM handler yourself, or you just copy it? Okay.
Yes. So there are two SMM handlers in coreboot. There's the geode, the VSA stuff. Well, actually, that's not part of coreboot, but the source code is available and it's used by coreboot. And there's the one for Intel platforms. No? I can repeat the question.
Okay. For starters, version 2, I think is what you recommend. But then, could I go on, have a look at version 3, or should I wait for version 4?
So, okay, good question. Should I recommend version 2, but is it useful to also have a look at version 3, or should one wait for version 4? What used to be version 2 is really going to become version 4, and I guess it's already on good way. Version 3 is definitely interesting to look at, and especially if you're using AMD G.LX hardware, then it's what you should use, I think.